All right, today we're going to dig into an idea that was born way back in World War II, but you'll see it's become incredibly relevant again. We're talking about Norbert Wiener and what you could call the architecture of control. And to really get why this matters so much for AI right now, we have to go back to the beginning, to the problem he was trying to solve.
So, before Wiener came along, scientists were really stumped by a pretty fundamental puzzle. When you look at any living thing, a plant, an animal, a person, it's obvious they're not just, bouncing around like billiard balls, passively reacting to things. There's something more going on. So the big question was, how do they do that? How do they do more than just react?
And the answer, it turns out, boiled down to one single powerful word. They regulate. They actively manage themselves to stay alive. And the story of how we figured this out starts in, of all places, the chaos of World War II.
Which brings us to what we can call the steering problem. See, before Wiener, science had this huge blind spot. It was pretty good at describing simple reflexes, knee-jerk reactions, but it really struggled to explain the active, goal-oriented, self-steering nature of life. And the guy who finally cracked the code was Norbert Wiener. He was this absolutely brilliant mathematician and philosopher at MIT. But he wasn't just some academic lost in equations. He was obsessed with how systems, both living things and machines, actually work in the messy real world.
So his big aha moment came during the war. His job was to figure out how to make anti-aircraft guns better at hitting fast-moving planes. And he realized something profound. For the gun to have any chance, it had to constantly take in information about where the plane was to predict where it was going to be and adjust its aim in real time. This whole idea of information guiding action was a total game changer. After the war, he gave it a name, cybernetics, from the Greek word for steering. And by 1948, he published his book that introduced this whole new way of thinking to the world.
So let's really break down what made Wiener's idea such a big deal. I mean, it was a complete 180-degree shift in how scientists thought about behavior.
The difference is just night and day. The old way of thinking was all about passive reflexes and reactions. It was basically like collecting and cataloging butterflies. But Wiener's view was all action. He gave us the language of feedback, of control, and of communication. These, he said, were the essential ingredients for any system that could actually steer itself through the world.
And Wiener himself put it perfectly. He said, any organism is held together by the possession and transmission of information. Think about that. For him, information wasn't just abstract data. It was literally the glue holding a living system together, allowing it to navigate its world.
But here's the thing. As brilliant as cybernetics was, it had its limits. You could say that Wiener had discovered this incredible new continent of thought, but it didn't quite have a detailed map of it yet. Let me put it this way. Cybernetics gave science the one absolutely crucial verb it had been missing: control. The idea that systems actively control themselves using information, that was the breakthrough.
But that powerful idea immediately raised a new, much trickier question. Okay, so it's all about control, but are all types of control the same? What's the underlying structure that makes one kind of control different from another?
Because without that structure, control was in danger of becoming this one big blurry idea. The kind of control a plant uses to slowly turn its leaves toward the sun, and the kind of control a cheetah uses to chase down a gazelle, they were both just lumped together as feedback, which kind of flattened out all the important differences, right?
Now, it's really important to say this wasn't some failure on Wiener's part. Not at all. He was simply working at the boundary of what was known at the time. The detailed understanding of evolution and biology that we have now just wasn't available yet. So he didn't have the tools to build a framework for all the different kinds of control problems life has to solve.
And this is where we can step in and build on Wiener's incredible foundation. There's a framework known as the 5-task model that lets us take that big, blurry idea of control and bring it into much sharper focus.
It's really important to see this model not as a replacement for cybernetics or as saying Wiener was wrong. Think of it more as a respectful thought experiment. It's a decomposition. It's like carefully taking apart a complex engine to see how all the individual gears and pistons actually work together.
So what this model suggests is that all of cognition is organized around solving 5 very distinct informational problems or tasks that evolution has thrown at life. They start simple, like controlling basic environmental states, and get progressively more complex, all the way up to controlling symbolic systems.
And this table here really makes it click. Controlling environmental states, that's our plant turning toward the sun. Controlling moving agents, that's a lion tracking a zebra. Perception and signaling, Think of a bird changing its song to find a mate. Group dynamics is like a hive of bees working together. And finally, that last one, controlling symbolic systems, well, that's us. That's a human following the instructions in a recipe. Each one is a fundamentally different kind of control problem.
Okay, so a deep dive into a theory that's over 70 years old. Why does any of this matter right now? Well, because it speaks directly to the huge conversations we're all having about artificial intelligence.
Think about it. Today's AI conversation is just full of words like optimization, prediction, scale. But what's often missing is a clear answer to the most basic questions. What is the AI actually trying to control? And for what purpose? It often lacks that clear task structure.
And this is where these two big ideas lock together perfectly. Wiener's genius insight was that control, through information, is the absolute center of intelligence. The five-task model then refines that by showing us that control isn't just one big thing. It's actually structured into these very distinct informational challenges.
So here's the main takeaway. You really need both of these insights. Holding them together is what gives us a real framework for building smarter AI. It helps us avoid the trap of confusing sheer computational power with genuine thinking. It lets us see the massive difference between a simple thermostat's feedback loop and the complex, layered control that defines real intelligence.
In the end, it really comes down to this. Norbert Wiener kicked open the door by finally giving a name to the concept of control. Frameworks like the five-task model are now giving us a glimpse of the incredible architecture inside the rooms that lie beyond that door. And that, right there, is a map we desperately need as we start to build the minds of the future.